Well, hello, algebra students and seekers of truth. In this video, we will review and then we will practice something new. We are asked here to simplify a rational expression, and just to review a little bit, what does it mean to be simplified? We're dealing with fractions. So if something is simplified, that means there are no common factors in the numerator and the denominator. Now this expression isn't factored yet, so let's factor it. You have a trinomial in the numerator and a trinomial in the denominator, and let's just review a little bit here. Well, how do we factor something like this? We make our big X, right? The top number, we put 16 in here, and this is just a useful mnemonic or a useful tool to help us. It's nothing particularly mathematical. And -8 down here. We want two numbers that add to -8 but multiply to positive 16. Okay, and in this case it's going to be -4 and -4, because -4 and -4 added together gives you -8, and when you multiply them together you get positive 16. Now we're going to do the same thing to the denominator. All right, so looking here at our denominator, if we were to factor that, we're looking for two numbers that multiply to -24 but add to positive 2. It takes you a little bit of practice, but you get 6 and -4. They multiply to -24, they add to positive 2. And so now we can say that f of x is really equal to, our denominator is going to be x plus 6 and x minus 4. Okay? That's what these two numbers help us to factor this into. In the numerator, we get x minus 4 and x minus 4. And you see here that we have an x minus 4 in the top, or in the numerator, and x minus 4 in the denominator. So these two, they're going to cancel each other, and what's left is x minus 4 and x plus 6. So this expression that we started with here, with a polynomial in the numerator and a polynomial in the denominator, can simplify down into this particular expression here. All right, on to our next example. This time we've got a bunch of different variables, a bunch of exponents, and so this is just a fine time to review and discuss, exponents and how that works. Okay, so if you're not sure, look back at some of your own notes, but otherwise let's get on with it. So the first thing that I'm going to do here is I'm going to change the negatives in the outside here into positives, and the way we do that is by taking the reciprocal of the expression that's inside. So this is squared, and this is 7x to the -2 y to the positive 3. Oh, I'm sorry, that should be flipped. All right, so 7x to the -2 y to the positive 3, and then 3x y squared. Same thing over here. Being raised to the -1 is the same thing as taking the reciprocal. So this is going to give me 14x squared y, so the denominator goes on top, and then 6x cubed y to the -4, that goes on the bottom. Okay, and then now I'm going to try to clean up the stuff on the inside. So anything again that is negative, I'm going to swap it. Okay, I take the reciprocal. So the top here, there's no negative exponents, so it's 3xy squared. And the bottom here, you have a 7, but x to the -2, we can take the reciprocal and move that to the numerator, and you have y to the 3rd, and you have a square here. Same thing over here in the numerator, nothing much changes, 14x squared y. And in the denominator, almost nothing changes, 6x cubed, and you have y to the -4th, so we take the reciprocal, and that becomes y to the 4th. Okay, and for these problems, we just try to go really nice and slow, try not to rush it and make silly errors. Okay, so now over here, notice here that I have a y squared and y to the 3rd. So when we kind of simplify that, that's just going to be 3. And then you have a y cubed, okay, subtracting y to the third, so that's just going to be y in the denominator. And you have an x times x squared, so that's just x to the third. And then the denominator, you have a 7 right there. And that whole thing squared, which we'll deal with in a moment. Same thing here, you have these two terms here that you can simplify. So 14, 6, and x cubed minus x squared is just x. And then these two terms here, y times y to the fourth, that's just y to the fifth. Okay. Now what we can do is we could square everything, and square here just means to multiply everything in here by itself, right? So this is going to be 3 squared. So I'll write this out. So this is, maybe it's better if we do this. 3x cubed over 7y times 3x cubed over 7y, and then 14x or 14y to the fifth over 6x. So when we multiply this across, it's going to give us 9x to the 6 over 49y squared times 14y to the fifth over 6x. So now we look at these powers. You have a y to the fifth up here and y squared. So that's going to, when you subtract, that's going to leave you y to the third. And then x to the 6 over x, so that's going to be x to the fifth. And then we can simplify this as well, so you can see that 9 and 6 here, the 9 and 6, 3 go into both of them, so you're going to have a 3 on the top and a 2 on the bottom. Then the 14 here, I'm just going to put a box here, and the 9, so 7 goes into both of them. So you're going to have 2 on the top and 7 on the bottom. And then once again, this 2 and that 2 cancels. Right, so now we have a relatively clean expression. It's just 3/7 x to the fifth y to the third. 3/7 x to the fifth y to the third as our final answer. So there you go. I hope this brings back some memories and re-jogs your mind a little bit as to how we deal with this problem, mostly the factoring, because we're going to be using that a lot as we move on forward and simplify more of these rational expressions. As always, thank you for watching. Ask for help when you need it, and have a wonderful day.